In this video, we are going to look at the different ways that you can use to select which variables to include into your multivariate logistic regression analysis. In our previous episode, we checked for the assumptions of binary logistic regression, and we shall be looking at the rest of the steps in our subsequent episodes. So consider liking and subscribing to the channel so that you don't miss out any of our episodes. Here is our hypothetical dataset that we want to use to demonstrate how to choose which variables to include into your model. We have got our outcome hypertension, which is a binary categorical variable, a requirement for binary logistic regression. We also have other 7 independent variables that we want to use to predict whether someone has hypertension or not. Of these, we have age, which is numerical, we have BMI and cholesterol. We also have sex, smoking, physical activity, and family history, which are binary categorical independent variables. Sometimes you have very many variables, even above 30 or 40, and you're wondering, how do I choose which variables to include into my model? So in this video, that's what we are going to cover. Choosing the right variables to include into your multivariable analysis model is very important, because having too few variables or having very many variables is very problematic to your model. You may overfit the model or you may lack precision in your model. So it is a balance between the two. Here are some approaches that you can use when determining which variable should I include into my model. One is the issue of sample size. If sample size is adequate, then use all the variables. Because by the time we collected this data about all these variables, for some reason we expected these variables to be related to our outcome or to be relevant for our research. So if you have enough sample size, include all the variables. 40 cases per variable is always recommended as adequate, whereas other books go as low as 10 or 15 cases per variable. What we mean is, if you have 10 variables into your model, then that means you need 10 times 40 participants to give you at least 400 participants as your sample size. If you have inadequate sample size and then you fit a lot of variables into your model, then it lacks sufficient power to detect significant differences when they do exist. So here, if the sample size is adequate, use all variables. However, if sample size is inadequate, which is the commonest scenario in most of the research, then there are 2 approaches that you can use. We have the statistical approach, and then we have the a priori criteria. So the statistical approach, that one involves running a bivariate analysis or bivariable analysis and kind of screen out of the many variables that you have, which ones have p-values less than 0.2. They could be relevant in predicting your outcome. At this point, we use a p-value of 0.2 so that we are able to capture even those negatively confounding variables. So basically what we are doing here is we are running each independent variable against the outcome so that we see the overall p-value. The lower the p-value below 0.2, then we consider that variable for multivariate analysis. It has shown us that it is relevant in predicting our outcome. We also have what we call the a priori criteria, where you select variables guided by literature regardless of the statistical significance. And this is commonly termed as the logical model building. You don't allow the software to dictate for you what to retain or what to drop. Instead, guided by literature, you select variables to stay in the model. Sometimes you use a combination of these 2. You may first use the statistical approach to select variables, and if there are some that have been dropped that you feel are relevant, you bring them back into your model. So regardless of which method you've chosen to use, fit all the selected variables into your model. So let's see this practically into Stata and see how it is done. So first we shall look at our sample size consideration. In total, we have 8 variables. So that would require us to have 40 times 8. That would be around 320 participants. But by looking at my sample size, I have a total of 150 participants, meaning I cannot use all these variables into my multivariate analysis. My model will not have sufficient power to detect statistically significant differences when they do exist. So we now consider options for selecting variables when sample size is inadequate. One is to use the statistical approach, where you run a bivariate analysis for each of the independent variable versus the outcome, and you choose p-values less than 0.2. To do this, simply go to Statistics, go to Binary Outcomes, and then Logistic Regression. In this dialog box, we specify our dependent variable, which is hypertension, and then each independent variable, and we see the p-value. Start with age. I submit this. In this output, we look at the overall p-value for our model. Our question is, by adding age, does it significantly improve the model compared to a null model or a model without any variable? And if it is statistically significant, then age significantly improves our model. And if it is less than 0.2, then we consider it for multivariate analysis. We do that for the rest of the variables. So next it will be sex. Then I submit. You can see that sex also has a p-value less than 0.2, so we shall consider it. Next, we shall have BMI. I submit this. This one has a p-value above 0.2, so we are not going to include BMI into our multivariate analysis. We do the same for smoking. Submit. You can see that even smoking has a p-value above 0.2. Same thing for cholesterol. Submit. Cholesterol will go in, and then we look at physical activity. Physical activity will not go in. Then we shall have family history. Submit. Family history will also not go into it. So this means that in our multivariate analysis, we are going to have only those variables with p less than 0.2. We can just pick a command from here, and then let me just remove this variable so that we start with age had a p-value less than 0.2. So we are going to put it there. Then we have sex had 0.2, so we are going to include it into our model. We have BMI was above. Then we had smoking status above 0.2. Then we had cholesterol. It had less than 0.2, so we shall include it into our model. Physical activity wasn't. Family history wasn't. So these are the variables that would be included in our multivariate analysis. Age, sex, cholesterol. Besides the statistical approach that we've just done here, we also have the a priori criteria, or selecting variables based on your literature review or what literature says. For example, if I've left out the other variables, BMI, smoking, physical activity, and family history, but literature suggests that physical activity and family history are important predictors of hypertension, then regardless of their statistical significance, I have to include this in my model. So I will include physical activity and family history into my model. And this is what we call logical model building. You don't allow the software to dictate for you what should be dropped or kept. Our variables sex, physical activity, and family history, remember, are categorical variables coded 1 and 0. So if you wanted to also show Stata that these are categorical variables, in your window through statistics, binary outcomes, and logistic regression, when you're putting in the variables, age, if you want to indicate that a variable is categorical, you use these 3 dots, click on them, and then you show that this is a factor variable. Then you specify this is sex, and then add to variable list, click OK, and then OK. Then you see that in the command there is an I dot before the variable name, which you can even just type. In our model here, we could just type in I dot to show that this is categorical. Even here, I dot, and sex I dot, and then enter. Then we can see that physical activity, the group coded 1, and then family history, the group coded 1, compared to the one coded 0. And if you have a binary categorical variable, the estimates you get by indicating that this is categorical are still the same estimates that you get even when you have not indicated. For example, physical activity, this is the value 0.686 and the p-value 0.348. Even when we've indicated that it's categorical here, it's the same value and also the p-value. If you found this video helpful, consider liking and subscribing to the channel so that you don't miss out any of our episodes. So next we shall look at how to assess for interaction effects among the independent variables in binary logistic regression using the chunk test or the likelihood ratio test. See you in the next episode.